Welcome back to Mishler Math. It is time to talk about linear inequalities in two variables. You remember an inequality is something where you use the signs greater than, less than, greater than or equal to, and less than or equal to. You remember those? Well, a linear inequality in two variables simply means we're trying something like this. AX plus BY, only instead of the equal sign, we're going to put one of these signs in between AX and BY and C. So instead of AX plus BY equals C, it's greater than, less than, greater than or equal to, or less than or equal to C. And there's one thing, A cannot equal 0, and B cannot equal 0. Other than that, it's exactly the same thing. So let's see what we're talking about when what that means. Let's try getting rid of this. And let's say I want to graph y is less than x plus 2. Well, here's how I do that. The first thing I do, and what's my y-intercept here? It's 2, right there. And what is my slope? Is 1. And so my points will go like this. Okay? You say, well, why don't I just graph the line and worry about the rest of it later? Well, because we don't even know whether to draw a solid or a dashed line. And the reason I say that is because, you see, I can't draw any kind of a line here because greater than, sorry about that. Make that a different color that I can see. Greater than or less than, this gives me a dashed line. Okay? Greater or less than or equal to or greater than or equal to gives me a solid line. You say, well, why would that be? Well, this means greater than or less than, like this says y is less than x plus 2. What that means is I'm looking for values below x plus 2, and this line, y equals x plus 2, is not included in my solution set. The points on that line do not solve this inequality. And so we use a dashed line to indicate that we're not talking about the points on that line. We use a solid line to indicate that we are talking about the points on that line. Just like here on the number line when we graphed a regular inequality, an open circle means that I'm not talking about that point. Closed circle means that that point is a solution. So this dashed line is the same as an open circle, and the solid line is the same as a closed circle. Okay? So, let's get rid of that stuff there. And so we can continue with what we are doing here. Y is less than x plus 2. So I'm going to make a dashed line here. Okay? And I can't use my fancy line tool because I have to make a straight line in order to do that, or a solid line in order to do that. So when I'm making a dashed line, you're just going to have to put up with my sloppy stuff. And so there's the line y equals x plus 2. Now I'm going to shade a whole region of this. And so I say, what side do I shade? Okay? And so to make things easy on you, all you do is look at your sign. Your sign says, your inequality sign, it says y is less than. Well, this is y, and so it says y is less than. That means we're looking for the y values below this line. Well, we'll look at where it crosses across here. Okay? We're looking for everything below this line. And so I'm going to shade. This is shading. This is me shading the graph. Okay? I'm going to shade all the areas below that line. And finally, I'm going to test this. And I'm going to get rid of that. I'm going to test this and see. And the easiest point I know to test is 0, 0. So let's put the points 0, 0, this is x, and this is y, of course. Let's put those into this inequality and see if it makes it a true statement. Is 0 less than 0 plus 2? Well, I would say that's a pretty good yes, it is. And so that's how you graph. And so remember, I want you to write these down now. These are 3 steps. Number 1, graph the line. Okay. Number 2, solid or dashed. Okay. A solid line would be greater than or equal to, less than or equal to. Dashed would be greater than or less than. Got it? And the third one, shade above or below. Okay? Shade above or below, and you do that by testing a point. First, of course, you look at up, above, or below, or greater than or equal, or less than, rather. And once you do that, you want to double check. You want to test a point. Okay? So that's how you do that. So let's try another one. I'm going to try one, let's see, y equals, oh, I'm sorry. No, I got one that's trickier than that. Okay. Negative 2x minus 3y less than or equal to 3. So, what do we need to do first? First, I've got to solve for y, don't I? So add 2x, add 2x. Negative 3y, I'm just taking this one and putting it over here, is less than or equal to 2x plus 3. Now I divide by negative 3, and ladies and gentlemen, remember solving inequalities? What do we do when we see the negative sign? When we divide by a negative number, we have to reverse the sign because I'm dividing by a negative number. So I have negative 2/3 x, and plus 3 over negative 3 is minus 1. So then, my y-intercept is negative 1 down here. And I've got negative 2/3 is my slope. So I go down 2 to the right 3. Down 2 to the right 3. And up 2 and to the left 3. Up 2 to the left 3. And now I get to use my tool because I'm going to make a solid line with this. And there is the graph. That's the line. That's the first step. The second thing I said dashed or solid. Well, I've already figured that out. It's definitely going to be a solid line. And that might be a little difficult for you guys to see. So I'm going to make this better than that, that's for sure. So I'm going to make this a little bit bolder so you can see that a little bit better, okay? Hopefully you can see that better there. So there's my line, okay? It goes through the y-axis at negative 1, and my slope is negative 2/3. I go down 2 and to the right 3, down 2 and to the right 3. Okay, so there's my line, and now I just need to know if I want to shade above or below. Well, look at my sign. Even though it's a little muddied up there, it's greater than or equal to. Y is greater than or equal to. So which side I'm going to shade? I'm going to shade above this. And so this is me shading above the line. Okay? So this area here is what's going to be shaded. And I'm going to test it. Again, I'm going to test it with 0 and 0. Only I'm going to test it with the original because maybe I made a mistake somewhere in my algebra. So I'm going to test it with the original. So I've got negative 2 times 0 is 0. Minus 3 times 0 is 0. Is that less than 3? And of course it is. So that works out really, really well. So that works out great. Well, there's a couple special cases I want you to pay attention to here. What about, suppose I have something like x greater than negative 2. Oh my goodness, what do I do? How do you do that? Well, this is so simple. I love these. These are so easy. This is negative 2 on the x-axis right here, isn't it? And if I have greater than, this is a dashed line. So I go the dashed line, vertical line like this. And say, well, what about greater than or less than? You can't go up or down. Yes, but x is greater than negative 2. Is 0 greater than negative 2? Yes. And so greater than negative 2 is over in this region over here. Okay? X greater than negative 2. Actually, this is kind of the same thing as 0, 1, 2, 1, negative 1, negative 2. Isn't that the same thing as this? Except the only thing we've done here is we've turned this open circle into a vertical dashed line, and we've gone and shaded to the right. X greater than negative 2, and it goes that way. Got it? One more. And I'm getting better with these things. I can tell you that right now. I'm getting really good. Y less than or equal to negative 1. Well, y equal to negative 1 would be a horizontal line at negative 1. And, oh, wait a minute. That's going to be a solid line, isn't it? Because that's greater than or equal to. So, oh, I'm sorry, less than or equal to. Less than or equal to means I'm below. So, that's how I do that. That's me shading below the line. I test 0, 0. Is 0 supposed to work? Is 0 less than or equal to a negative 1? No, it is not. So 0 is not supposed to be shaded, and sure enough, it's not. And that's all I got for you today. Thank you so much.